Hello, welcome everybody to the ISP Insights Podcast. I'm your host again today. My name is Martin Simmerling, and I'm very happy to announce our today's guest, Zac Cronauer. Good morning to your place. Um, yeah,
Good morning. How are you?
I'm fine. Thanks, Zac. I hope you're doing also fine.
Yes, it's a great day here in the United States.
As every day I can imagine. Really. Maybe start just out at to all the listeners like who don't know you, who are you?
Yes. So my name is Zac Cronauer, as Martin said. I am the head of fiber initiatives at Blue Ridge Communications. I've been here about 10 years. Um, I have worked in different fields in the engineering department here at Blue Ridge
Yep.
and have made my way up into the head of fiber initiatives. I started as a field engineer. I worked in the head ends for a while, and then I was a design systems engineer. Before that, I was in the US Army as a multi-channel transmission systems operator and maintainer. It's a big name.
This sounds important, definitely.
Yes, big name. It was a great opportunity, and that was really what started me in the field of communications and actually helped me start my career in fiber.
Yeah. Thanks, like so far. That's also what you can find when you look about informations about you. And previously, you've done your studies in a different field, so it was really like the military times which brought you there into communications, and obviously caught your interest. Am I right?
Yes, yes, that's exactly right. So I started in satellite communications was my first and primary MOS, and which is your military occupation.
Yep.
And then I had the great pleasure of being deployed to Iraq in 2009 to 2010, which is where began my fiber experience.
Yep.
We were placed in charge of all strategic communications in what's called fibre. So um, we were in charge of all the outside plant, and we had a fully redundant fiber ring.
Yep.
And back then, I knew very little about what that meant. The Army actually brought in the Fiber Optic Association of America, which is commonly referred to as the FOA, and they actually certified us as CFOT. So it's called the Certified Fiber Optic Technician.
Okay, I can imagine that this is the place. I mean, you said it like where the origin lies for fiber technology, obvious. That's what I understood, and
Yes.
it's obvious that it's like of highest priority and importance that everything is working out. So you said four times redundant. Did I get it right?
Yeah, we had a fully redundant. Yeah, so like you said, fiber is the word of the day, in our times as broadband's
Yeah,
needed for everybody. So
yeah,
I was very fortunate about 10 years ago, 12 years ago now, to get my experience started in it.
yeah. And when you came to Blue Ridge, um, did they start building fiber networks back then in those days, or did they already exist there and you joined the team, or was it like hour zero for you to start out with this here?
Yeah, so that's a great question. When I arrived at Blue Ridge, we were about 15 years already building fiber networks. And Um, what I didn't realize as a very young person was how much bigger the world is in fiber. In the military, we dealt with very small counts, and fortunately, Blue Ridge built very large counts very early on in fiber, and we built when we built our network. So there was a steep learning curve in quantities of fiber and and
Yeah,
understanding and learning and but I always say it was very fortunate that Blue Ridge started fiber very early on, maybe in the late 90s, and unfortunate because it was so new and so new back then that we kind of didn't know where we were going in the beginning of it, but we were fortunate enough to be placing it in the air and in the ground.
yeah. But this sounds really interesting. I mean, like being maybe one of the first ISPs I can imagine back then in those days
We
with
were
fiber
one of the
optic.
first, I believe, and I know there was an article written, and I actually know the person, Ron Vogt, who was the first one in Blue Ridge to have a cable modem in America. So that's one of our claim to fames. So
Oh, I'm sorry.
that's okay.
Okay. Oh, yeah. Okay. I was about to ask further information about companies. So Blue Ridge also originates from the cable plants, and
Yep. Yeah,
uh,
we are a very we're a tier two cable MSO now, and we started a long time ago when an antenna was placed on what's called the Blue Ridge Mountain, and they ran a coaxial line down, and it's been growing ever since.
yeah. When was it? Did you mention it?
I believe it was in the 1950s. Yeah.
Yeah. Okay. So long story with cable experience,
Yeah.
but now also again long story for fiber. I mean, it's more than 20 years, uh,
Yes.
and more than 10 years, I believe, for you as well in the company.
Yeah, about
Um,
10. Yep. Yeah,
yeah.
so I have about 12 years total experience with fiber, and I had the great fortune of being able to do it all.
Yeah.
Back when I started, it was a mostly outside plant, building and splicing and enclosures and doing commercial application enterprise solutions. And after that, you start to build, you start to troubleshoot, you start to understand backbone networks, and you can really start to grow and learn how to troubleshoot and what to see in your fiber plant, how to design it, where you can go wrong, what you can do right,
Yeah.
and really start to try to what future proof your network, right, is one of the things that fiber can do best, is understanding that once you get that in the ground, you can do almost, or up in the air, you can almost do anything with it.
Yeah. And now, since you've seen a lot along the way through these different positions, now you made your way to the head of the fiber initiatives at Blue Ridge Communications. So your job today is also, like you said, network planning, but also training field technicians. Am I right?
Yes.
Yeah.
Yes. So that is one of the main priorities that Blue Ridge has, is training our techs constantly, and one of those things is in fiber. As the world pushes fiber in deeper and deeper into the network, one of the things
Yeah.
that you need to really focus on is training your technicians to be able to do the work that is required of them.
Yeah.
And it's being able to properly handle fiber optic cabling, and fusion splicing, I always say, is the simplest part, right? All the rest of it is the hard part, is planning and preparation, and understanding how to route fiber, and the different types of equipment that are needed to make sure your project is successful. Anybody can splice fiber, but to make it nice and plan it perfectly is a completely different animal.
Okay. This really sounds interesting. So when you're talking about training the stuff, this is like 80% about planning and extending the network, building new or accessing new areas, and maybe 20% troubleshooting here, or is
Yeah,
this
yeah,
completely
I would
different?
say, instead of an 80-20, I would probably say 60-40. A lot of what we have to do is maintain what we already have, right? Is like I said, we have this long history in fiber optic cabling, and with that comes some errors in the past, and trying to identify that and fix those issues is also a major part of what our technicians are required to do. And that's an understanding of, when you arrive onto a scene or in an outage, is what are you looking at, and getting an idea of not being intimidated by the fiber there, being able to see the issues, or see the problems, or how to fix it, and then like you said, the rest of it is the future, where we're going with it. And we've been very fortunate that Blue Ridge is investing pretty heavily in our fiber technologies,
Yeah,
and but it also gets more confusing at that time, so.
yeah. Can you imagine? Yeah, world is growing, a lot of different solutions.
Yes.
When you're talking about mistakes in the past, how do they occur to you? It's like, I can imagine it's not necessarily an outage in the end, but maybe you just think, okay, we did it like this back then, but nowadays we would do it in a different way, like redesigning networks, connecting in a different way, or
A mixture of both. So 20 years ago, and maybe even now, fiber is getting a little bit more expensive. Fiber is more cost effective nowadays, but back then it was a very expensive investment. So
yeah,
you would see, if we built it into a town, we would build, say, the exact number of fibers we needed, instead
yeah,
of saying, well, this could grow and we could see
yeah,
this expand, and then you would overlash more, instead of building a bigger fiber network to begin with, and kind of really taking an eagle-eyed view of where you're building and what the potential is, not necessarily what you currently have, but it's a major investment at that time. And now we're kind of seeing where we're able to kind of reclaim a lot of our fiber from the past. So with the new technologies of multiplexing and different types, whether it's CWDM or DWDM, we're starting to see anywhere that we didn't have a lot of fiber, we can kind of reclaim that with channelized fiber now. So it does make up for the past mistakes a lot easier now than it ever did.
Yeah. So from my understanding or knowledge here, I would say maybe in the beginning you've been building maybe point-to-point connection networks, and nowadays, or when improving, when you're like reaching out to more even potential customers, homes and areas, there might be the option of like a physical splitting of fibers, which we call a PON network. Correct
Yes.
me if I'm wrong.
No.
Also the option of using like different wavelength channels, right? So.
Yes. So you hit the nail on the head. The different choices you have now, you can do a physical split, or a light. You would just physically split the light, percentage wise, or to your point, you can actually multi wavelength, do different types of channelized wavelength through one single fiber. So it gives you a lot of different options, depending on what's available to you and your budget, right? Because everything's got to go back to that, or where you see your customer growing, right? If it's a large MDU or multi-dwelling unit or high rise or building, how you best to feed that, and the amount of customers that are going to be available to you. So, to your point, where we started as a very point to point, where we got a fiber to point A, from A to B. Now we can get from A to B to C to D to E. So, there's a lot more.
Yeah. So, and if you're talking about network planning, I mean, there's this technical point of view, different solutions, and obviously, I guess most important factor oftentimes would be the cost of all this experiments of the building. So depending on putting fibers down to the ground, or maybe having more active technology, intelligent technology.
Yes. So that's what you have to figure out, right? Is how best to do it is if you have a fiber near, can you build a little bit of an extension, or can you channelize it, right? And say, hey, well, we already have this fiber, let's throw some gear on each end and make this a multi-point system. So that's a great point.
Are there any other dimensions which I don't see, or maybe also our listeners don't know, when you're talking about planning those networks?
So things to consider when you are designing and planning that network is what technology you would like to use. There's different applications for every solution, right? If it's a commercial or enterprise customer, you would do things differently depending on whether you are monitoring the fiber system, or if it's considered what some people call dark fiber, and a point to point is whether you're just leasing the fiber, or whether you're actively monitoring it, and that changes how you design it. Whether it's a residential area, do you have the capability to launch PON? As we see, there's going to be a major transition, in my personal opinion, from DOCSIS right over to what you're seeing as a PON or next gen PON solution. And that kind of changes how you're going to operate, right? So the fiber previously goes to a node and then your coax out, and we were fortunate, we did a step between, and we launched RFOG, which is RF over glass. So we still utilized a RF solution inside the home, while putting the fiber next to the home. And then, now we're able to step that one phase forward and running fiber all the way to the cable modem. And all of those different technologies require different architectures. So you have different solutions in your network that you got to see what's best for your location or geographically. Whether it's a centralized split, if you have access to a cabinet on the ground or on a pole, and you home run all of your drops back to one centralized area, or if you run a distributed and you have different taps along the way. But you know, and vendor, right? You know, which vendor is going to give you the best pricing that's going to help you out, and that's going to offer you, you know, some vendors offer training and they send field application engineers to help train your staff. So there's a lot that can go into this.
Yeah, sounds absolutely like this, and it sounds really like comprehensive thing to do. I don't know if you can talk about it, but I can imagine you're not the only one doing network planning for privileged communications.
Yes.
How large would you, or is your team, or?
Yep, we have a large, you know, we have a good internal team here, and I'm very fortunate to be a part of it. We have some really smart and really good leadership team, from our NOC to our engineering department, which is our design engineering, you know, from our construction staff, and then ultimately to our techs who are building it in the field. You know, they deserve a lot of credit. You know, they're able to roll and learn, and learning is a huge key, right? Being able to open to learn and want and the want and drive to learn new technology. It's difficult. We see it, you know, all the time with all the, you know, we're sitting on a Zoom from across the world. So
right, this is awesome. Absolutely.
yes.
It's wow, wow. Maybe one other topic, Zach. Now we talked a little bit about the planning and all the aspects of it, and your team around it. And you also have colleagues, and the mission, or of course you need to enable the service all the time at the best possible quality. And if you're thinking about troubleshooting, what's the difference? Okay, you're not coming from the DOCSIS world, not from the cable plant yourself, but maybe you know from your colleagues. You have a more comfortable position here. You're talking about troubleshooting in a fiber optic network.
Yes, yeah. So I would leave the coaxial and DOCSIS network to the experts. I wouldn't consider myself an expert there. You know, I do know that what I always say between the fiber and the coax is more susceptible to noise, right? You're gonna have ingress and egress from the cable modems and the cable plant.
Yeah.
Whereas in the fiber world, you know, it's light levels, right? You know, you're dealing with a power. You know, you have optical power meters that you can plug in, and you can see, you know, is your light level within spec. And then you have, you know, the most famous one, you have what's called an OTDR, which is an optical time domain reflectometer. It's a fancy word, but you know, you can characterize your fiber from there. You know, and that's going to get you your point to point, right? It is an OTDR to see, you know, does this link, you know, reach from A to B, you know, and that's going to be important. But as we talked about, that's a simplistic view, right? Two very simple solutions to troubleshoot. And you have what's cool with fiber as well, and many people, it's very common, but it's called the visual fault light, or your red light, and you can actually put visual red light on fiber, and you can see it on the other end. And then, you know what I always say is that's a great tool for identifying, but you don't want to just base whether the fiber works off of visual light. And then you can kind of step it into next gen technologies, and that's, you know, characterizing multi wavelengths, like we talked about with DWDM and CWDM. OTDRs now are getting a lot more complex, and you can actually some are just channel checkers. If you know that it's a CWDM plant or network, then you can get an OTDR or an optical power meter that can, you know, read all the different light levels that are on one single fiber. And then you can also get OTDRs that can transmit enough power that it'll reach through your splitters, you know, and it'll say, hey, this is an actual splitter in the field. We recognize this through our different there's different proprietary technologies that make it a little bit simpler, and say, you know, here's a splitter, here's a splitter, here's a splitter, and this actually can proof out your network from there. So troubleshooting wise can get a little crazy and hectic, depending on the type of network you've placed in. But it's important to try to get the right tools for your technicians to know, you know, and training that, you know, gives them the right knowledge and information to troubleshoot it, because the name of the game is keeping outage times down, right? The customers are the most important.
Yeah.
and you want to make sure they're back in service as fast as possible.
Yeah. And I mean, now you mentioned a lot about, or some points about different things to look at, where the, yeah, what's the typical cause of such an outage? Is like dirty splicing, or is it troubleshooting? If there are troubles occurring in an optical network, is it like they occur when building them, mainly, maybe 95% of the time, or also due to, I don't know.
Yes, no, that's a great question. I would say a lot can occur while building a fiber optic network if you're not proofing the network you're building.
Yeah,
For a long time, I guess that I would say internally, without the knowledge of proofing what you just built, right? Your construction team went out there and built a fiber plant. And they said, hey, the fiber's there. Tell the customer it's up and running. And the
yeah.
customer plugs in and it's not working. And it's like,
Right.
well, you
No,
need to
that's correct.
confirm the span that you just placed. So, we're getting, we worked our way into the processes of plant proofing, making sure that
Yeah.
each span has an OTDR shot to go along with it
Mhm.
before we tell the customer that it goes on, that it can go online. And that's a simple point to point.
Mhm.
In our residential, we have our optical budget. So when we build our network, we check each tap as we build it to make sure it falls within our um our power budget.
Yeah.
So it can be arranged, depending on the CPEs that you choose, the modems, that accept, say up to a minus 26 or 27 before it sends into an alarm because of a low light issue, right? Residentially, that's
Yeah.
going to be your biggest issue, is that there's either low or no light. And a lot of what you're going to see there is dirty connectors, as weird as it sounds. The choice you have to make when deciding residentially is whether you're going to fusion splice, mechanical splice, which is a very less common choice, or you do what's considered a pre-connectorized solution. And that's when the vendor manufactures your fiber optic connectors already on, right? Or they come pre-connectorized, so you're dealing with a
You
little bit
just
more
plug in
maintenance.
the,
So you're just plugging and playing then. So you've got to look operationally at your speed to deployment. How important is it?
yeah.
What resources you have. What experience you have with your techs. If you have multiple techs that understand fiber and can fusion splice efficiently and can go up in a ladder or up in a bucket truck and can fusion splice efficiently and effectively, then maybe being able to fusion splice your drops and different parts of your fiber network in is a good choice for you. Or maybe you don't have that access, or maybe you're using contractors, is what you're seeing a lot of.
Mhm. Yeah.
And maybe a pre-connectorized solution is better because you're not spending as much time training. You're just worried about cleaning connectors on each side.
Yeah.
So there's a lot to consider when deploying your residential network.
Right. And I think this is also a good point in time when you're deploying the network or you're building it. Then you have the, yeah, you said it, you transition there to build and prove
Yes.
with the network. So I think this is a good time, because the network is not, you can step by step prove connections and see if it's working or not, maybe right out in the field. And in the case that connection is like established and proved, and the customer's already online, and then he's calling and, hey, no internet, same problem again. What to do now? Or maybe first question, what can occur to such a kind of network, like over time? If you build.
Yeah. So it's a great question. And over time, I always say it's an interesting thing. What we do in the broadband world is we take our most important and vital asset and we put it outside, right? Our
Yeah,
fiber is living in the outside world, and there's a lot that can happen. But like you said, repeat issues. You can in a fiber and coax world, the drop to the house is normally an issue, right? If connectors are loose or dirty,
mm,
and monitoring it remotely is the key. Is can you stop a truck roll, right? Can you
yeah,
avoid a truck roll? Can you have your customer service representatives have access to monitoring the CPE devices in the home and see can they talk to the cable modem? What is the cable modem saying? You know, what is the issue? Is it a noise? Is it SNR? Is it MERs on a DOCSIS world or fiber? And what we talked about with next gen PON is, and what something we're seeing is our transmit power is or the receive power of the ONU or CPE device inside can be at say a minus 24, but the transmit power is on a different wavelength, right? In next gen, it could be at 1270 to 1290 nanometers, and that's transmitting back at a minus 27, you know, or sometimes we're seeing about a 3 dB difference between the receive and the transmit, and that can cause an issue. It could cause the modem to not properly, you know, turn on or ramp up. So you know, what tools and devices you give your CSRs and your level 2 technicians or your NOC to be able to see and monitor those CPE devices is going to be the key to success.
Yeah. Okay. So what I understood is like receiving the right signal, and of course signal quality, which is dependent on the way the light goes here through the splitters. Are there also like interference effects? So like there's a problem in one point of the network, and this is radiating back into your network. And this is possible for the cable plant. Are there also similar for fiber?
Yeah, in a DOCSIS world, I believe that you know is a very common occurrence where you're seeing noise travel back into your plant. Fiber, you know, is going to be a little bit different. In a next gen PON, you're not going to see that issue occur too much because of it being an IP or network based. Because I believe it's a TDMA timing issue then, because all the IPs are labeled out. But one of the issues you will see is depending on your network architecture is if you do have an issue somewhere else, you know, and you choose a distributed or cascaded split, and there's an outage down the road, that could knock out, you know, a huge leg or portion of your network, right? So the difference being is where a house couldn't necessarily one singular house couldn't cause issues back on a fiber network. An issue further down the road could cause a major issue or outage that doesn't necessarily have any impact in your local area. And that's more of a concern, I think, as well.
When you're talking about troubleshooting here, I guess what we talked about right now mainly was like troubleshooting from field technicians. So they're going out in the road. Or do you have a percentage, maybe a number, how much troubleshooting takes place like really in the field, and how much of the troubleshooting can already be seen on the NOC level?
Yeah, I would say that the NOC level probably has a lot more visibility than ever before. You know, if given the right tools, right? If you invest in the monitoring software and systems in that you put into place that can talk to the CPEs, you know, that you're seeing them, you know, you can eliminate a lot of truck rolls based off just that. You know, whether you know that the CPE device is working, and it could be an in-home issue, you know, maybe it's a Wi-Fi or an ERO problem. If the modem is reporting, you know, back that it is working and up, and you can ping it, and or you can see, you know, maybe there is an issue in the future, right? You see that a modem going in and out, you know, over time, if you're monitoring it correctly, you know, that hey, there's a plant issue in this area. Maybe we should identify, you know, or send a tech out and investigate beforehand before it actually becomes a customer complaint. You know, everything that you do for your CSRs or level 2 or NOC, that you invest in monitoring and you know, technology for them is going to save you in the long run as you go to troubleshoot, instead of, you know, keeping your techs out, you know, running from outage to outage. It's more of a controlled pick then, where you're not worried about, you know, having every truck roll for every outage that's called in. You know, you can identify these more readily available. So I would say it's actually probably you would hope for almost an 80%, you know, in the NOC to CSRs troubleshooting, and the 20% in the field, where they should almost have all the information ahead of time.
Yeah. So it's a lot about proactively maintain your network to plan things. And I mean, right now you've been talking NOC sees like information from the CPE and devices along, or they also able to look at like different devices along the way, so from the backbone to the customer, the end-to-end view, can or are they also capable of determining, okay, it's not a problem, not an issue at the CPO or customer side, but it should be at XYZ, this and this splitter tab along the way, or even if they are, yeah, I don't know to which extent they are active or passive here.
Right, right. Well, and to your point they can see, this CPE, or, and then for a next gen PON, or even any sort of PON, you have your OLT, which is your optical line terminal. Well, that's your node, right? So
Yeah,
if that's operating efficiently and effectively, the NOC can maintain and monitor that. And
yeah,
then you can base it off, CPEs in the field. Can you isolate the issues to a port? Can you isolate it to a neighborhood? Is it all off one tap?
yeah,
Is it all off? So that's something that the NOC could identify, or a call center, or anybody that's responsible for that type of troubleshooting,
yeah,
given the ability to, right? Given the software, given the monitor system, everybody, not everybody, but the goal should be to monitor the network that you're putting in place,
right,
and that's going to be key, is the communication, between the NOC and the engineering, right? A lot of the people in charge of the network are your design engineers that have designed it and placed it into an asset network, management solution, or any sort of CAD or design program, and they can tell you exactly, where it is, and hopefully then, you can have a proactive response to troubleshooting, instead of sending in a tech, investigating, finding something, and kind of work your way backwards, and that can take a lot longer to do.
right. But in case they are able to monitor the network properly, they can give you the right spot. If the drug roll is unavoidable, let's say it like this, then
Correct. Right. Truck roll is unavoidable. There's an outage. You have to send a guy, giving them the most, sending a technician, giving them the most information possible before they arrive, you know,
yeah,
removes the guessing out of it. It keeps the outage time significantly down. And, a customer with a half an hour outage is not as mad as a customer that's been out for 4 hours or 5 hours or 6 hours, while you're kind of running around on the back end. Right.
yeah, that's absolutely true. So this again breaks down like to a system, maybe not only monitoring, but also like yeah, communicating, ticketing, dispatching approaches. So like having maybe a common view or the right information at the right spot here at the right place for your field technicians as well. Zach, from your point of view, how important would you see such a kind of solution to be like agnostic for technologies maybe, but also for vendors, I can imagine.
Yeah, no, absolutely. And I think it's really important, and it's something that you have to really, look at from a provider standpoint, right? Is if, you get locked into a proprietary software solution or a proprietary fiber network, there's all sorts of proprietary solutions that lock you into, the type of fiber you're using, the connectors on each end, the panels that are available to you, the drops, the NIDs, from beginning to end. If you choose a proprietary solution, that's your solution moving forward. If your lead times expand, that can cause your network to suffer. And if you keep your network, whether it's a software open source or open, not, so tightly,
Yeah,
locked into a solution, you're a lot more readily available to solve a lot more problems, especially in the fiber world. We have very common form factors that are used, connectors, fiber types, all of that are used throughout the industry, and that makes it a lot easier for the provider to choose from different selections, and keeping, whether it's price down or lead times down,
yeah,
or anything, and that's something that you have to really look at as as a provider as well.
Yeah, of course, I like this idea with the background here.
Yes.
What I always think of here at this point is like I cannot imagine any ISP or network operator being interested in being subjected to any kind of vendor lock-in along the way because of the drawbacks you just talked about. How do you see like the forces maybe between the network operators, providers, and the hardware operators on the other side? So how can we work on the hardware operators to say, okay, you don't necessarily have to lock down your system because of advantage X, Y, Z. What's your opinion on this here?
That's a great question. I think it's relationships maybe is one of the biggest things that drives a lot of that. I think it's good to have a relationship with your vendors and maybe, if they invest in you as the provider, then, and you get into a good situation as a company, that could be something that you could see going a more proprietary solution, getting the right response from the vendors. But they, at the same time, those can change. So you also have to protect yourself as the provider, and you have to say, well, we understand, but we also have to make sure that we're future proofing, and that we make sure that, 10 years down the road, this isn't going to cause us a major issue.
Right.
And that's something that you really have to think about before you get into it. We had a project that we got very locked into a proprietary solution. We got a lot of good pricing on it, and then the lead times expanded and we missed a lot of deadlines, and we had to kind of change streams and go back to an original form factor, and then we were able to complete our project within a good time frame after that. So it was a good lesson for myself, and it was a good lesson for our team, to try to understand, maybe getting locked into a proprietary solution isn't a good idea. But I think the original, to answer your original questions, a lot of it is relational between the vendors and the providers. So
yeah. I mean, I think I can agree on this experience here as well. Typically, naturally, we are human beings. At some point, it comes to communication, and I guess
yeah,
it's all about communication. Maybe even in a kind of triangle relationship between software providers, hardware providers, and the ISP on or network operator on the other side. I think we can make a point here. It was a really interesting conversation with you, Zac. I hope and I think so also for our audience here. A little bit more in deep dive today, I would say, but I really enjoyed it. Nice impressions here from your side as well.
Thank you. I appreciate it as well, and I thank you for having me, Martin. And
sure.
it's been a pleasure.
For me as well. And yeah, I wish you all a nice weekend as of now. And to the audience, thank you very much, and see you next time. Bye bye.